LangGraph implements a streaming system that surfaces real-time updates from LLM invocations, enabling responsive applications by progressively displaying output tokens before complete responses are ready. This artifact demonstrates async streaming with multiple LLMs, where token streams are filtered by metadata tags to isolate specific model outputs. The setup initializes two tagged chat models for distinct tasks, defines a state schema to manage topic and generated content, and constructs a graph that invokes both models concurrently while streaming their outputs. The streaming mode is configured to yield message chunks with metadata, allowing selective display of tokens based on model tags.
From typing, import typed dict. From LangChain, chat models import init chat model. From LangGraph, graph import start state graph. Hash the joke model is tagged with joke. Joke model equals init chat model equals GPT-4. 1 mini, tags equals joke. Hash the poem model is tagged with poem. Poem model equals init chat model equals GPT-4. 1 mini, tags equals poem. Class state type dict. Topic, SDR. Joke, SDR. Poem, SDR. Async def call model state, config. Topic equals state and topic. Print writing joke. Hash note. Passing the config through explicitly is required for Python 3.11. Hash since context var support wasn't added before then. https://docs python org/3/library/asyncio task html hash creating tasks. Hash the config is passed through explicitly to ensure the context vars are propagated correctly. Hash this is required for Python 3.11 when using async code. Please see the async section for more details. Joke response equals await joke model, invoke. Role, user, content, write a joke about topic. Config. Print \n writing poem. Poem response equals await poem model, invoke. Role, user, content, write a short poem about topic. Config. Return joke. Joke response content, poem response content. Graph equals. State graph state. Add node call model. Add edge start, call model. Compile. Hash the stream mode is set to messages to stream LLM tokens. Hash the metadata contains information about the LLM invocation, including the tags. Async for MSG, metadata in graph a stream. Topic, cats. Stream mode equals messages. If metadata, tags equals joke. Print msc content end equals, flush equals true.
This code demonstrates async streaming with multiple LLMs and filtering in LangGraph. The pattern uses two tagged LLM models, joke model and poem model, to generate content concurrently, with the call model function handling both invocations. The graph streams LLM tokens using stream mode equals messages, which yields tuples of message chunks and metadata containing invocation details. The key mechanism here is the metadata filtering, where the tags field in metadata is used to selectively print only joke tokens. This approach is particularly useful when you need real-time updates from specific LLM invocations while ignoring others. The explicit passing of config to invoke is required for Python 3.11 to ensure proper context propagation in async environments. This pattern is valuable for applications requiring selective streaming from multiple LLMs, though it adds complexity with the explicit config passing requirement in older Python versions. The trade-off is between real-time responsiveness and the overhead of managing async context propagation. Let's break it down.
From typing, import typed dict.
Imports typed dict from the typing module. which enables creating dictionary types with specific key-value type annotations for type checking and code clarity.
From LangChain, chat models import init chat model.
Imports the init chat model function from LangChain's chat models module, which provides functionality to initialize and configure chat-based language models.
From LangGraph, graph import start state graph.
Imports start and state graph from the LangGraph graph module. Start is a constant representing the entry point of a graph, while state graph is a class for constructing stateful workflow graphs in LangGraph.
Hash the joke model is tagged with joke. Joke model equals init chat model equals GPT-4. 1 mini tags equals joke.
Initializes a chat model using the GPT-4 1 mini model and assigns it to the variable joke model, tagging it with joke for potential filtering in streaming scenarios. The tags parameter associates metadata with the model instance, which can be used later to identify or filter outputs from this specific model when streaming LLM tokens.
Hash the poem model is tagged with poem. Poem model equals init chat model equals GPT-4. 1 mini tags equals poem.
Initializes a chat model using the GPT-4 1 mini model and assigns it to the variable poem model, tagging it with poem for potential filtering in streaming scenarios. The tags parameter associates this model instance with a specific identifier that can be used later to filter streamed outputs when using LangGraph's messages streaming mode.
Class state type dict.
Defines a class state that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a type dictionary for managing state data in a structured way, where each key's value type can be explicitly specified.
Async def call model state config.
Defines an asynchronous function named callModel that accepts 2 parameters, state and config. The function is declared with async def, indicating it will perform non-blocking operations, likely involving I/O or external API calls. The parameters suggest this function will process some state data and configuration to interact with a model, though the specific implementation details aren't visible in this segment.
Topic equals state and topic.
Extracts the value associated with the key topic from the state dictionary and assigns it to a variable named topic. This retrieves whatever topic information is currently stored in the graph's state for use in subsequent operations.
Print writing joke.
Prints the string writing joke to standard output, serving as a simple progress indicator during execution.
Joke response equals await joke model, invoke.
Asynchronously invokes the joke model to generate a response, storing the result in joke response. The invoke method suggests this is an asynchronous operation, likely calling an LLM or API endpoint to fetch a joke. The await keyword indicates this line will pause execution until the joke generation completes.
Role, user, content, F write a joke about topic.
Creates a list containing a single dictionary representing a user message with role, user, and content that is an F string generating a joke request about a specified topic variable. This appears to be formatting a prompt message for an LLM conversation, where the topic will be dynamically inserted into the joke request.
Print \& and writing poem.
Prints a new line followed by the text, writing poem, to indicate the start of poem generation.
Poem response equals await poem model, invoke.
asynchronously invokes the poem model to generate a response, storing the result in the poem response variable. The ainvoke method suggests this is an asynchronous operation, likely calling an LLM or similar model to produce output. The exact parameters passed to ainvoke aren't visible in this segment, but the line clearly initiates an async call and awaits its completion.
Role, user, content. F. Write a short poem about topic.
Creates a list containing a single dictionary representing a user message with role, user, and content that is an F string interpolating the variable topic into a prompt asking for a short poem about that topic. This appears to be constructing a message in the format expected by many LLM APIs, where messages are structured with role content pairs.
Return joke. Joke response content, poem. Poem response content.
Returns a dictionary with two keys: joke, containing the content from joke response, and poem, containing the content from poem response. This packages the generated joke and poem outputs into a structured format for the caller.
State graph state.
Creates a state graph instance initialized with a state class, establishing a graph structure where state defines the data model for node transitions and state management. This is the foundational setup for building a stateful workflow graph in LangGraph.
Add node call model.
Adds a node named call model to the graph. This node will be part of the graph's execution flow, and when invoked, it will execute the logic defined in the call model function or component. The node is now registered in the graph and can be connected to other nodes or used in the graph's workflow.
Add edge start, call model.
Adds a directed edge from the start node to the call model node in the graph, establishing that the call model node should be executed immediately after the graph starts.
Compile.
Compiles the LangGraph workflow into an executable graph structure. This method call finalizes the graph definition and prepares it for execution, enabling the streaming capabilities defined in the graph configuration.
Async for MSG. Metadata in graph a stream.
Iterates asynchronously over a stream of message chunks and metadata from the graph's a stream method. Each iteration yields a tuple containing a message, chunk typically an LLM token or segment, and associated metadata details about the graph node and LLM invocation. This enables real-time processing of LLM outputs as they're generated within the graph.
Topic, cats.
Creates a dictionary entry with the key topic and the value cats. This represents a simple key-value pair where the topic is explicitly set to cats.
Stream mode equals messages.
Sets the streaming mode to messages for LangGraph, which configures the system to stream LLM outputs as tuples containing message chunks and metadata from any graph nodes where an LLM is invoked.
If metadata, tags equals joke.
Checks if the metadata dictionary contains a tags key with a value that is exactly the list, joke. This is a conditional check that evaluates to true only when the tags are precisely that single element list, enabling filtering or branching logic based on joke-tagged content in the streaming context.
Printms content end equals, flush equals true.
Prints the content of MSG, content to the console with a pipe character, at the end instead of the default newline, and forces immediate output without buffering. The flush equals true parameter ensures the output is written immediately rather than being held in a buffer. This implementation showcases LangGraph's async streaming capabilities with selective output filtering. The core pattern involves initializing two tagged LLM models for distinct tasks, then using a state graph to manage concurrent invocations while streaming results. The key insight is how metadata tags enable real-time filtering of token streams, here only displaying joke tokens while ignoring poem outputs. The explicit config passing requirement for Python 3.11 highlights the trade-off between async context propagation and real-time responsiveness. By combining tagged models with message streaming mode, the system achieves selective real-time updates from multiple concurrent LLM invocations, demonstrating LangGraph's ability to handle complex async workflows with fine-grained output control.
The graph streams jokes in metadata's shadow, while poems hide in the config's quiet corners.